if you were a square, you would be a perfect square. Is the worst pickup line you could use ever, so don't use that. Learn from me. But here we do have a polynomial, p of x, I guess for perfect square. And this m term floating around. So that's just a constant, just a number. And of course we have our x's, that's our input. Yeah, so if you forget what a perfect square is, I'll draw you one. Actually, no, that's not a perfect square. I came prepared. That is a perfect square, right? Where all sides are the same. So it could be x and x, or it could be x plus 3 and x plus 3. And if we were to express that as an area, that would be x plus 3 squared. Right? We don't have any constant on the end, like a plus 4 or something. Perfect square, x plus or minus a number, could be 0, could be 100, brackets, squared. Now graphically, have a think of what this looks like. Right? It's a parabola. What would the x-intercept or intercepts be for this function? Right, so we have y equals our x and y axes. So this is the standard parabola. Oh, standard parabola, right? At the origin, shifted 3 units to the left, like so. So it has one, or a repeated x-intercept at x equals -3. So that's a key property of a perfect square, right? It sits along the x-axis. So we can move it anywhere along here, to the right, to the left. It could be at the origin, but we cannot move it up or down. All right. So with that in mind, how many... Well, there's a few ways of approaching this problem. Let's do the clever way. It saves us some time. So how many solutions or intercepts does a perfect square have? So a perfect square has exactly one intercept or solution, or root. Let's use root. Yep. Because if we lifted it off the x-axis, it would have none. If we took it below the x-axis, it would have 2. But in both of those situations, it would not be a perfect square. And you might recall the discriminant, right? The bit underneath the square root symbol in the quadratic formula. That tells us about the number of solutions of a quadratic equation, or the number of intercepts of a quadratic function. So if we want exactly one root or one intercept, the discriminant must equal 0. So let's use that and express a, b, and c, which are in terms of m, and try to find this relationship for m. So we have b squared, which is m plus 1 squared, minus 4ac, 4 times a, which is 2m minus 1, times c, which is m minus 4, must equal 0. All right, so just to clarify, for this polynomial p of x to have one solution, one intercept, this equation must be true. And now it's in terms of m, which we don't know what m is. However, since we have m in this equation, we could determine what m must be. So with that in mind, let's expand, simplify, group like terms, and try solve for m. So expanding the first term gives us, well, I'll just write it out in full, so I don't make any mistakes. So I just wrote m plus 1 twice because we're squaring it. 4 times 2m times m 2m squared, 2m times minus 4, minus 8m, minus 1 times m, minus 1m, minus 1 times minus 4 plus 4 equals 0. Now let's expand the m plus 1 times m plus 1. That's m squared plus m, 1m, excuse me, plus 1m plus 1. And then here we'll expand the 4. So minus 4 times 2m squared is minus 8m squared. Minus 4 times minus 8m is plus 32m. Oh, let's just group that minus 8m minus m first. So what is that? Minus 9m. There we go. Just make it a bit simpler. So minus 4 times minus 9m is plus 36m. Minus 4 times positive 4 minus 16 equals 0. Group our like terms. So m squared minus 8m squared minus 7m squared. M plus m is 2m plus 36m is 38m. Plus 1 minus 16 is minus 15 equals 0. And now we have a quadratic equation from the discriminant in terms of m. So we can solve for m. We could factorize it, or go menu, equation, degree 2 polynomial, because it's quadratic. Our a is negative 7, our b is positive 38, and our c is negative 15. And we can hit solve, and we get m equals 5, or 3 over 7. Alright, so we got two solutions for m. Makes sense, we did have a quadratic that we were solving, this one here. But which one makes sense? Or do both? So let's have a think. Going right the way back to the top to p of x. Or, actually, let's go back to this example here. If we were to expand that out, what value would the constant c be? Alright, so have a think about that. So y plus 3 squared. What would the constant be? So that's y plus 3 times y plus 3. And you know when you expand the last two terms, that'll give us positive 9. But what if we had y minus 3 squared? What would the constant term be? Minus 3 times minus 3 is actually still a positive number, positive 9. So, for a perfect square, this constant, in this case m minus 4, has to be greater than 0, or equal to. Right? If it's not, and it's a negative number, that can't be a perfect square. So we can therefore conclude m must be equal to 5, and we can ignore the solution 3 over 7.